All right. Hi, guys. So today's lecture is going to be over what's called the activity series. Excuse me. So I have the notes here. Um, I'm going to post. I'm going to post a filled out version of these notes. That'll look kind of like this. Okay. I'm going to post a filled out version, but I'm going to kind of walk online. But I'm going to walk you through like kind of sort of how it works on this unfilled out one. So it'll have that, and it'll also have a second page, which is the actual activity series sheet. So if you can print it out, you might want to print this out um, to use with all your other stuff, or just make sure you kind of know where it is so you can pull it up when you're doing the homework. Okay. All right. So what the activity series is it's a list of reactivity of metals from most reactive at the top to the least reactive at the bottom. This is used to determine if a cationic single replacement reaction will occur. Okay, so as a reminder, a cationic single replacement is where you have an element and a compound, and the cations, you've got a positive element by itself and a positive one in the compound, and they switch spots. So this activity series determines if it'll happen or not. So for the reactants, on the reactant side, on the left side, if the single metallic element is above the metal cation currently in the compound, the reaction will occur. If the single metallic element is below the metal in the cation currently in the compound, the reaction will not occur. Okay, so the analogy I give for this is kind of weird, but it works. All right, um, so imagine, so we've got a positive element by itself, right? And we've got a positive and a negative in our ionic bond here, cation and anion. So imagine the compound, positive and negative, as a guy and a girl laying on a beach together. Okay. Now imagine the single element as a guy that walks up. So if the guy that walks up is like really buff or whatever and strong, and the guy that's laying on the beach with the girl is kind of wimpy, then the strong guy is going to come up. He's going to kick sand in the wimpy guy's face and take the girl. Okay, he's stronger than the guy. So if the element that's alone is stronger or more reactive than the element in the compound, then the element that's alone is going to take the anion. Okay, now, imagine the same scenario: guy and girl laying on the beach, but this time the guy laying on the beach with the girl is the really strong buff guy, and the really wimpy guy comes up and he tries to take the girl away. Okay, well, nothing happens. The strong guy just like puts his palm, Heisman's him right in the middle of the forehead and holds the wimpy guy off. Nothing happens. The strong guy and the girl are still together. The wimpy guy can't take her away. So, same thing here. If the single element is weaker or less reactive than the element already in the compound, no reaction will happen because it's not strong enough to take the anion away. Okay, so let's take a look at the first example. Aluminum and lead 2 nitrate. Okay, so we're seeing if this reaction will happen or not. Okay, so we look. So our cations are aluminum and lead, Pb. So we look on our chart here. Okay, aluminum is here, and lead, Pb, is down here. So aluminum is more reactive than lead. So aluminum should end up with the anion. So if we look here, aluminum is by itself, right? That means the reaction is going to occur. So the aluminum is going to take the anion. Okay, so we're going to get, now to make that, you've got to do charges and crossings. So aluminum on our periodic table, right? On our periodic table, aluminum is a +3. Nitrate, NO3, off the polyatomic ion sheet, this thing. Okay, nitrate is a -1. So cross down, right? We end up with Al NO3 parenthesis 3. Okay. And plus now, so the aluminum's not tonight, so now lead is alone. Okay, and when it's alone, it's just itself, just Pb. Okay, all the elements when they're alone are just themselves except for your Hofbrinkel, the diatomics. Those 7 when they're alone are diatomic, but everything else is just itself like that. Okay, so aluminum is higher than lead, so the reaction occurs. Okay, and then you can balance it. You know, we would need a, let's see, what do we need? We need a 3 here, a 2 here, a 3 here. Right? Yep. Okay. All right. Let's take a look at the second example. So we've got tin and cobalt 2 sulfide. So again, if we look on our periodic table, tin, Sn, and cobalt. So cobalt is here, tin is here. Cobalt is more reactive than tin. So if we look, cobalt's already with the anion. So nothing's going to happen. The tin's too weak to take the sulfide away. So we're going to get no reaction. Nothing happens. So if you had a solution of cobalt sulfide, cobalt 2 sulfide, and you put like tin metal in it, nothing would happen. Literally, the tin metal would just sit in there. There'd be no reaction. Okay. All right. The last one is the same type of idea. This is just turning words into the formula and seeing if it'll happen. So the first thing we're going to do is check and see if it'll happen. But to do that, we've got to know what the substances in the compound are. All right. So we've got calcium, Ca, plus hydrofluoric acid. Now, remember, this is an acid, right? So all acids start with H+. The hydro tells us our anion is monatomic, so it'd be fluoride, which is F-1 from the periodic table. Okay, we cross down, we get HF. All right, now let's see if this will occur. Okay, so we're going to look, we've got calcium and hydrogen is our 2 cations. So calcium is here, hydrogen is down here. So calcium is more reactive than hydrogen. So if we look, calcium is more reactive than hydrogen, so it will take the fluorine away. So we're going to end up with calcium is a +2. Fluorine, we've already said, is a -1. So we cross down, we get CaF2, right? Okay, and now what's alone? The hydrogen. Okay, but remember, hydrogen is part of Hofbrinkel, the 7, HOFBRIN and Cl. It's a diatomic when it's alone, so it should be H2. Okay, now we can balance. We would just need a 2 in front of this, and we're balanced. Okay. So that's pretty much it. Your homework, there are 7 that are like this, that are like I already give you the compounds in the beginning part, and then there are 3 on the back that are words. You got to see if you have to turn it into it and then see if it'll occur or not. Okay. If it doesn't happen, you just write no reaction. Okay. If it occurs, then write the complete balanced chemical equation. Okay. Now, if you are typing this in the homework, if you're typing this in the Google Doc, remember, use control comma. You hold down the control and the comma to get subscripts, to get the subscripts down here when you're typing stuff in. And then you hit hold control comma to get it out of that too. Okay, I do not want a bunch of I don't want a bunch of stuff like this, you know. Like I don't want a bunch of stuff like that in the Google Doc if you're typing it. Okay. All right. If you have questions or anything, don't forget we have office hours today from what is it, 9 to 10:20 and 2:40 to 3:10. Otherwise, you can message me and we'll set something else up. All right. Talk to you guys later.